Hello, scholars. Welcome to Lesson 3, Session 2 on performing sequences of rigid transformations. We're going to try to move through this pretty quickly. I want to talk about sequences of transformations, and we're going to spend just a second reviewing what rigid transformations are and if they still apply to sequences of transformations. So, this says Kamani and Jake each performed the same two transformations on figure T. Right here, you see it. But not in the same order. Kamani's sequence, he reflected over the y-axis, followed by 4 units to the left. Jake's sequence is 4 units to the left and then reflect over the y-axis. Will the sequence map the figure T on the same final image? I hope you already know the answer. Like, I wish they would have given us a little more graph here to explore this, but did you see what I did when I was reading these? I said Kamani reflected over the y-axis. I'm right here now because we have to be the same distance away from this axis when we reflect, and then he moved 4 to the left. Jake went 4 to the left, and then he reflected. Same distance, right? So he's much closer. So Kamani's way over here, and Jake's right here. Obviously, these are not going to put us in the exact same spot, right? And we see that on the next page. Like, the book did it for us here. Thank you, book. And here's Kamani. He reflected, and we end up here, and then we moved over 4 more. Where Jake, he moved 4 to the left and then reflected. He is so much closer than Kamani is. And we can see that in the points here as well. But I think the point is, no, they don't end up in the same spot. Order matters. The order that we do a series of sequences, a series of transformations, a sequence of transformations, there we go, is going to matter. Now, can I come up with some instances where it's not going to matter? Yes. But for the most part, we've got to be careful about what order that we do our transformations in, because it'll make a difference of where we end up. Okay. Now, we're going to pause for just a moment here and answer this question. How do we know that both final images are congruent, meaning same size, same shape? Yes? Let's remember what this is. Same size, same shape, congruent. How do we know that they're congruent to the original figure T? And this is all I'm going to say, because we only used rigid transformations. We did a reflection and a translation. Those are both rigid transformations, which means they don't ever change the size or shape. Okay? That is our definition of rigid transformations. So we can do as many rigid transformations in a row as we want to. We'll never change the size or shape of the figure. Okay, we're only in a little bit, but I think it's time for the random fact of the day. And here it is. Did you know that some cats are allergic to humans? Yeah, I know. Random fact of the day. There it is. Okay, this says, number 2 says, translate figure T3. Oh, T, here it is. T. Hi, T. 3 units to the left. Then reflect the image across the x-axis and draw the final image. Okay, I can do that. I am translating. That means I'm picking up every point and I'm moving it. We're moving it 3 units left. Okay, let's do it. 1, 2, 3, boom. 1, 2, 3, boom. Okay. 1, 2, 3, boom. 1, 2, 3, boom. There it is. Okay, we did our translation. I'm going to call this t prime. And then reflect it across the x-axis. Okay, so well, this is going to stay, this is 1 away, so this has got to be 1 away. This is 7 away, so it's got to be 7 away. I just looked up here to see where 7 is. This is 2 away from the x-axis, so it's got to be 2 away. This is 4 away, so it's got to be 4 away. That's a reflection. Let's call this T double prime. Okay. Then perform the transformations in reverse order. Okay, so we're reflecting first. Let's reflect. 1 away. 7 away. 2 away. 4 away. Dot, 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 dot. Dot, 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 dot. Dot, 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 dot. Dot, 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 dot. T prime. And then we're going 3 to the left. 1, 2, 3. Oh, we ended up on the exact same place, didn't we? Yes. Yeah, do both sequence map T onto the same final image? Yes. Yes, they in fact do. Interesting. How do we know? Well, we can see it. Duh. So there are some cases where we can do them in different orders and end up in the same place. But we're going to have to be careful about that, right? What can be different about a figure and any of its images after a sequences of translations, reflections, and rotations? What can be different? Well, not always, but they sometimes going to be in a different location. I don't need to write the word different again. Location might be different, or position. We usually say position, don't we? Position or location might be different. What else might be different? The orientation. There's only one R in orientation, isn't there? The orientation might be different as well. Okay. In this case, neither were different. Well, we changed position, right? We changed position. But what's always going to be the same? They're always going to be congruent images. So always going to have the same size and shape, as long as we are only performing rigid transformations. Okay, that's all for this. This is pretty quick and easy. I don't think we need to do any of the apply it's because you have ways to practice on your own. So go ahead and get to it and let me know if you have any questions. Thank you.